In this video, we'll install, review, and run benchmarking tests on the Peppermint OS Trixie distribution. We downloaded the ISO image from the official website. The recent version, Trixie, is available for download through SourceForge. We wrote the ISO file to a USB drive and booted the computer to start the system in live mode. Peppermint OS, a United Kingdom-based distribution formerly based on Ubuntu and now on Debian, hasn't released a new version in 2 years. The last was Bookworm with a respin over a year ago. We waited for its live environment to load and show the desktop. We clicked on the install icon, carefully selected the desired language, specified the preferred location and time zone, customized the keyboard layout type, chose the appropriate target disk for installation, and let the installer auto-configure the necessary partitions smoothly and efficiently. We entered full name, username, password, confirmed the settings, and began the installation process without any issues. This community-driven distro is designed for users of all ages and skill levels, focusing on providing a minimalist desktop with only essential tools and customizable themes. After the process finished, we restarted the computer, logged in again, and entered the password. Peppermint OS is based on Debian and Debian. It offers extensive software repositories to meet most needs, with additional options available through third-party sources like Flatpak, Snap, and AppImage. We noticed the Wi-Fi was not detected, so we powered off, changed the Wi-Fi dongle, and restarted. Now it worked perfectly. After selecting the available network from the list, we successfully connected to the Wi-Fi by carefully entering the correct network password. Once authenticated, the connection was established without any issues, allowing us to access the internet smoothly. We explored the pre-installed applications, which were intentionally minimal, focusing only on essential tools and utilities and designed to provide a clean, simple, and distraction-free user experience right out of the box. We opened the terminal application to begin working, then adjusted the font size to make the text easier to read and improve overall visibility. After that, we proceeded to update the system to ensure all software and packages were up to date. Once the update was complete, we installed several useful tools, including Sysbench for benchmarking, Fastfetch for system information display, and Firefox as our web browser of choice. We ran Fastfetch. It reported kernel version 6.12.48, based on Debian 13, using XFCE and X11. RAM usage at startup was 1.04 GB, and the system used 6.32 GB of disk space. We verified the distro, kernel version, free memory, and disk usage and confirmed support for the Y2038 bug fix. Using systemd analyze, we measured a boot time of 58 seconds. We then ran the Sysbench tests, CPU to measure the processor's raw computational power through mathematical calculations, memory read and write to evaluate the speed and efficiency of accessing and storing data in RAM, disk read and write to assess the performance and responsiveness of the storage device during data transfers, thread test to analyze how well the system handles multiple threads running simultaneously, and mutex test to measure the effectiveness of locking mechanisms that manage resource access in concurrent processing. We also used the top command to monitor RAM usage while opening Firefox, with 1 window, then 2 with video playback, then 3, and finally 4 windows. After that, we shut down the system and reviewed the results. Final summary: Peppermint OS based on Debian 13 with kernel 6.12.48 installs about 1,500 packages, runs XFCE4 with X11, uses around 1 GB of RAM at startup, and takes just over 6 GB of disk space. It supports Y2038, boots in under a minute, and shows the GUI in 10 seconds. Firefox uses about 600 MB of RAM, increasing by 300 MB per additional window. Sysbench tests showed the CPU handled 1,000 events per second with 1 thread and 3,300 with 5 threads, with slightly higher latency as threads increased. Memory read and write speeds were about 7 and 5.5 GB per second, respectively. Disk read and write speeds were roughly 10 and 7 MB per second. With 5 threads, 1,500 events per second were processed, and the mutex test showed moderate synchronization at 11 events per second. Overall, the system feels responsive, largely thanks to XFCE. Memory usage remains low, though disk space requirements are somewhat high for a minimal setup. One notable drawback is limited support for certain Wi-Fi dongles. That's it for now. We'll keep installing, reviewing, and benchmarking other Linux distributions with Sysbench. Stay tuned for more.